Welcome! We're going to see in this tutorial how to create a simple queuing system with Java modeling tools. In particular, we're going to use JSIMgraph, which is the graphical simulator of JMT. To create our first model, we need to create a source, which is the entry point for jobs in our queuing model. Then we create a queuing node, Q1. And lastly, we create a sink, which is an exit point for the jobs. We then connect these components, and we are almost ready to run our first simulation. What we need to do next is to specify what kind of jobs enter in this system. So in order to do so, we click on Class, add our first class, and require that this is an open class. So open classes are classes of jobs that arrive from a source. So you see here that you can specify which source this is in case you have multiple sources. We will choose source 1. Then we can click on the edit button here to specify the interarrival time distribution. This is the statistical distribution of the time between successive arrivals from the external world into our queuing model. So how much time it will take for the source to generate the next job. There is a choice of a number of distributions like gamma, normal, exponential, deterministic, and others. We will go for an exponential distribution. You can specify the exponential either by its parameter lambda or the mean value of this interarrival time. The parameter lambda in the exponential distribution has the interpretation of the rate of the distribution. So if we type, for example, 2, this will mean that on average 2 jobs will arrive per unit of time into our system. So we give OK, and we give OK also here. We now need to configure our queue. First of all, in the queue section that you can see after you have double-clicked on this queue, you can decide in what order the jobs will be processed. So by default, JMT chooses a first-come, first-served scheduling policy. So we leave it in this way and move to the service section, which specifies which speed the queue will process these jobs. So if we click on Edit, we need to make sure that the queue is faster than the arrivals, because otherwise it will be saturated by too many arrivals if it cannot process them fast enough. So we write, for example, that the processing rate here is 4 jobs per unit of time. So for example, 4 jobs per second. Then we can give the OK, and we can try to run our first simulation. If we do so, JMT reminds us that we need to define a number of performance indices, which are the measures that we want to collect in our simulation. So we click on this error, and we are sent to this dialog window, which allows us to specify what we want to measure. So for example, we might want to record the response time of the jobs that visit this queue. So we say that these are the jobs of class 1, and we select Q1. Now we give the OK, and JMT automatically starts the simulation. So as you see, after some computation, we see that the average response time is about 0.5 unit of times. And what you see in this diagram on the right is the progress of the JMT simulation. So in blue, what you can see is the value of the average response time as the simulation progresses. In red, there are the confidence intervals for this value, which give us a measure of the uncertainty about this prediction. In green on the back, you can see some values of the response times that have been collected by JMT throughout the simulation. As you can notice, the confidence intervals do not start immediately as you start the simulation. And this is because JMT initially analyzes a group of samples and uses this initial estimate to generate the first set of confidence intervals for this system. And this concludes our first analysis with JMT.